This video is sponsored by London Christian High. Visit at londonchristianhigh.ca for more information. Hey everybody, welcome back. We're going to be doing a video on energy level diagrams, and then we're going to dive into pi and sigma bonds, and then if we put those two together, then we're going to be learning about bond hybridization. So without any further ado, we're going to get on started here. I hope you enjoy. So, energy level diagram, what even is it? Energy level diagram is a graphical representation of energy's various orbitals at the atom. So before we take a look at an example, we're going to take a look at the different sections. So we have an S section, which covers where the line is covering. Then we have a D section, so that covers a big part of it. Then we have the P section here. And at the bottom you'll see F, but we're not going to be talking about that. So let's start with carbon. Let's find carbon on the periodic table. Alright, and there is our carbon, so let's take a look at the different groups we passed through. So we have 1s, 1 electron, 2s, 2 electrons, 1 orbital, 2 electrons. Next we pass through 2s, we go through 2 electrons again and 1 orbital. Next we go through 2p, 1, 2, 3, 4, 5, 6. So that's 3 orbitals, but we're only using 2 electrons, so 2p, 2 electrons, 3 orbitals. Next, let's do phosphorus. Let's find phosphorus. There it is. Let's look through the groups we go through. 1s, there's 2 electrons, 1 orbital. 2s, 2 electrons, 1 orbital. 2p, 1, 2, 3, 4, 5, 6. 6 electrons, 3 orbitals. We're using that entire 2p. Next, we have 3s, which is 1, 2. 1 orbital, 2 electrons, 1, 2. To get to phosphorus, 3, 4, 5, 6. So we have 3 orbitals and 3. Alright, let's do one last energy level diagram. We're going to be taking a look at copper right here. So let's take a look at all the orbitals we're going to be going through. And note that we're going through the d orbital this time. Right, so starting off with 1s, 1 orbital, 2 electrons, 2s, 1 electron, 2 electrons, 1 orbital, we're right here. Now we're moving on to 2p, 2p. We have 6 electrons, and we have 3 orbitals. Fill all of those up. Alright, next we're going to be passing through 3s, 3s. We have 2 electrons and 1 orbital. Next we're going to be moving on to 3p, 3p. We have 3 orbitals and 6 electrons. Alright, now we're going to be moving on to 4s. So we have a full orbital with 2 electrons. All right, now we're on to the d orbital. So something you have to remember for the d orbital is it's going to be one group up. So it may look like 4d, but it's actually 3d. So keep that in mind. So here it would be 4d, 5d, 6d. All right. So now we're on 3d. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to copper. But we have 10 electrons in total, so that means we have 5 orbitals. 1, 2, 3, 4, 5. And we have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's what a copper energy level diagram looks like. Electrons. All right, awesome. Let's move on to our next concept. So we're going to take a look at pi and sigma bonds. So first, let's look at pi. Any second or third bond made with any other atom. All right, and sigma bond is first bond made with any other atom. So there's it up there, just to take a look at for quick notice. All right, so before I name these, try and name which ones. All right, perfect. So there it is. We have 2 pi, 1 sigma. Let's take a look at another one. Once again, try and name before I name them. So we have 3 sigma bonds and 1 pi bond. So that means 3 first bonds and 1 second bond. All right, awesome. All right, so since we looked at 2D model of what pi and sigma bonds look like, we're going to take a look at the 3D model, even though it's still on paper, so it's technically 2D. Anyway, so this is how it would look. So the sigma bonds would overlap each other, as you can see in the blue, and the green, they are parallel to each other, and it is connecting the other orbitals together, and it creates a bond. So if we put these two together, we are going to be learning about bond hybridization. So let's take a look at this. So we are going to be hybridizing 2p and 2s. So what's going to happen if you hybridize those? It's going to be equaling sp. And 2p is going to equal double bonds, so that's our pi bonds, and sp is going to equal single bonds. All right, so let's name what kind of bonds each of these have. So it is all sigma bonds, as you can see here. So that means there's going to be 4 orbitals and 4 electrons in sp. So this is how it's going to end up looking. 1 s, 2 electrons and 1 orbital. sp3, we're going to be taking 3 p orbitals, and there's going to be 4 electrons in it. All right, so this is the carbon energy level diagram. So let's break this down even more. So this is, again, carbon energy level diagram, but it's completely split up. So we're going to move 2p up along with everything else to make room for our hybridized. So we're going to take a p and we're going to take an s, okay? So to make this work, we need to take all of the orbitals. So there's going to be 4 orbitals, and we're going to take all of the electrons. And since we took 3 orbitals from p, there's going to be sp3. All right, let's move on to the next example. All right, so once again, let's name all of the different bonds. So now we have 1 pi and the rest are all sigma. So this means there are going to be 3 orbitals and electrons in sp and 1 orbital and electron in p. Sorry, that thing is wrong. All right, so here's our carbon energy levels, and here's what it's going to end up looking like, and here's it completely broken down. All right, so we need to have 3 orbitals, so we're going to take 2 orbitals from p and 1 from s. That's what it's going to end up looking like. Remember to put the 2 beside the p because we took 2 orbitals from p. All right, moving on to our last example. Let's name all the different bonds. So we have 2 pi, 2 sigma, which means there's going to be 2 electrons and 2 orbitals in the sp and 2 orbitals and electrons in p. So here's our energy level diagram of carbon. Here's what it's going to end up looking like. And let's break it down even more. All right, so let's first make room for our hybridized of sp. We are going to need 2 orbitals and 2 electrons, so we're going to take 1 from s and 1 from p. So remember to put the 1 beside the p, and that's what it's going to end up looking like. All right, thanks for watching, and let's look over what we learned. We looked at energy level diagrams, we looked at pi and sigma bonds, and finally we looked at bond hybridization. Thanks for watching.